Hi there! We are on our last section of Chapter 1. We will be discussing exponents and order of operations. So our goals today will be to evaluate exponential expressions, simplify algebraic expressions with exponents, use the order of operations agreement, and evaluate mathematical models. So let's go ahead and start with our warm-up. Right? So let's see if this number is a solution of the equation. So you've got two ways to go about this. You could either actually solve the equation and see if you get -4 for your variable m, or you could simply plug in a -4 wherever you see an m, and then see if the left side of the equation yields the same constant as the right side of the equation. If that's the case, you'd have an identity statement and -4 would be a solution. If you got different numbers on either side, you'd have a contradiction, therefore implying that -4 would not be a solution. So let's see what we've got going on. So 5 times -4 decreased by 1 all over 6. Is that equal to 3 times -4 minus 2 all over 4? So here's where I plugged in the -4 for m. Alright, so here we go. We get -20 minus 1 all over 6. Is that equal to -12 minus 2 all over 4? So we'll have -21 over 6. Is that equal to -14 over 4? Well, when we reduce both sides of the equations or simplify, you see that we can divide out a 3 from each of these and we would get -7/2, and on this side we could divide out a 2 and we would get again -7/2. So -7/2 sure is equal to -7/2. So answering the question, yes, -4 is a solution of 5m minus 1 divided by 6 equal to 3m minus 2 divided by 4. Okay, so here we go. Now that we're all warmed up, let's go ahead and actually, I think these are more warm-ups. So why don't you guys go ahead and pause the movie and do these warm-ups and we'll see how you did. Okay, let's see how you did. 14 added 2. So I'm thinking here we ought to we'll leave a space and I'm going to say plus 14 because that's adding 14 to something else. And then over here we've got the product of 4 and -10. So the product of 4 times -10. And so here we go. And that one is just an expression. Okay. Now we're called upon to simplify this. So this will equal to -40 plus 14, which is -26. Okay. Alrighty. So, next up, the quotient of -18 and the sum of -15 and 12. So again, we have this situation, the quotient of something and something else. So the -18 will go first, then we'll have a divided by to represent quotient. And then the sum, so the quotient of, over here the sum of negative 15 and 12 would be represented in parentheses. So we'll have negative 15 plus 12. Okay, so now solving this one, we will get negative 18 divided by, doing the parentheses first, we'll have a negative 3, and then we'll get an end result of positive 6. Alright, so hopefully you're all warmed up. The definition of a natural number exponent. If b is a real number and n is a natural number, b raised to the n power is equal to b multiplied to itself n times. So this here is n times. Okay. So here notice that exponentiation is repeated multiplication. So b to the n is read the nth power of b, or b to the nth power. The expression b to the n is called an exponential expression. Alright, so first example, negative 5 raised to the third power. So by definition, this is going to be negative 5 multiplied to itself 3 times. Now we have an odd number of negative signs, so we'll have a negative, and then 5 times 5 times 5 is 125. So we're all done. Negative 12 squared is negative 12 times negative 12, which is a positive 144. Okay. Now be careful because the negative was inside the parentheses, so that was part of the base that was being exponentiated. We'll be coming across other problems where the negative kind of goes along for the ride after the exponentiation. Okay. All right, so order of operations. Perform all operations within grouping symbols like parentheses. Evaluate all exponential expressions. Do all multiplications. And divisions in the order in which they occur, working from left to right. Finally, do all additions and subtractions using one of the following procedures. You could either work from left to right and do additions and subtractions in the order in which they occur, or, rewrite subtractions as additions of opposites, combine positive and negative numbers separately, and then combine these results. So whatever works best for you, you know, different people like to do, you know, use different techniques. So that is something you'll have to decide on your own or do a combination. All right, so here we go. We are going to simplify. All right, so why don't you go ahead and pause the movie and see how you do with these. All right? Okay, let's see how you did. This guy, remember, we've got division and multiplication are on the same hierarchy since division is defined by multiplying by the reciprocal. So this, we'll do the 40 divided by 4 first to get 10, and then we need to multiply that result by 2. So this 40 divided by 4 was 10. And then at the end of the day, we are going to get 20. Now, a lot of times students sort of try to write in your own parentheses. Remember, don't do that. If they were supposed to have parentheses there, they would have been written there in the first place. Okay, so number 2. This one will be -5. 7 minus 2 is 5. Minus 3 times 4 minus 7 is -3, all over -13 plus 5, because minus a minus is plus. So we'll get -25, minus a minus is plus, so we'll get plus 9. And then -13 plus 5 is -8. So this is going to yield a result of -16 divided by -8, which is +2. And we're all done. Put your happy box. Okay. How'd you do? Good. Alrighty. So next up, we have 3 times 5 being multiplied. So that's 15, and we're going to square that bad boy. We're going to subtract. Now be careful. This is 3 times 5 squared. So it's 5 squared is 25. So this will be 225 minus 75. So at the end of the day, you'll get 150. Okay. All right. So this one, your favorite, fractions, right? So here we will have, let's rewrite this as -4/7 plus 2/5, because minus a minus is a plus. We're going to be multiplying that to -3/8 plus -1/9. So what we're going to have here, we need to find common denominators. Okay. So we will have the common denominator for the first one is going to be 35. So we are going to have our -4/7, and we're going to have this plus 2/5 hanging out over here. We're going to need to multiply by 5/5 for the first and 7/7 for the second one. And then over here, we're going to have -3/8. The LCD on this one's going to be, I think, 72. So I'll leave some space, and we'll have -1/9. And we'll be multiplying by 9/9. And then this one will be multiplying by 8/8. Okay. So if you were kind of holding off on it till I did this, why don't you give it a try, and let's see how you do in a minute. Okay, so, whoops, in the green still. Let me get the black pen back. We've got negative 20 35ths plus 14 35ths times negative 27 72nds and then plus a negative 8 72nds. Okay. So then what we're going to kind of be encroaching on the space for this guy, we'll have a negative 6 over 35 for the first one, and then times negative 35 over 72. And that works out nicely because do you see that the 35s will divide out, and 6 goes into itself once and into 72 12 times. So at the end of the day, we are going to have, we have two negative signs, so it's going to be a positive 1/12. Okay. So let's take a look at example 3. Why don't you go ahead and try example 3 and see how you do. Okay, so here we have like terms because we have the same variable x raised to the same power, which is a 2. So we just need to combine the negative 6 plus the 18. So we'll get 12x squared, and we're all done. Now let's take a look at the next one. We're going to be distributing the 4, so we will get 28 times x cubed minus 20. This is equivalent to this. And then we'll be subtracting. So we'll have 16x cubed minus 2, and then plus 1. So the 2 being distributed through that quantity resulted in this here. So then we'll have 28x cubed minus 20, and then we're going to have minus 16x cubed minus 1. The minus 1 is a result of combining the negative 2 plus 1. And remember, when you have a negative on the outside, you flip this, remove the parentheses, and you flip the signs of everything inside. So this negative in front of the parentheses changed this stuff to this. So then, combining like terms, 28 minus 16 is going to be 12x cubed and minus 19. All right, last one. We'll have 6 minus 5 times 8 minus 2y plus 4. So again, this negative on the outside of the parentheses changed the terms inside to that. So we will have, now don't be suckered into this 6 minus 5 right here. You got to multiply before you subtract. So we'll have 6 minus 5 times, I'm going to combine that 8 plus 4 to get 12, and we'll have the minus 2y. Now we distribute the 5 through, so we're going to get a minus 60 plus 10 of those y's. So this guy here resulted in these two terms. And then combining the two constants, we're going to get negative 54 plus 10y. We're all done with that page. All right. so here we go. Applications. In Palo Alto, California, a government agency ordered computer-related companies to contribute to a pool of money to clean up underground water supplies. The companies had stored toxic chemicals in leaking underground containers. Yikes. The mathematical model C equals 200 times x, all divided by quantity 100 minus x, describes the cost, denoted by C, in tens of thousands of dollars, for removing X% of the contaminants. So, find the cost in tens of thousands of dollars for removing 50% of the contaminants. So, remember we start with C equals the quotient of 200 times x and 100 minus x. So in for x, we're putting in 50, because remember it's x%. So 50 is the coefficient to the percent. So 200 times 50 over 100 minus 50. So everywhere that we see an x, we're plugging in 50. So this yields a result of C is equal to, well, we have a 2 times 5, which is 10, and we have 1, 2, 3 zeros. So 10,000 over 50. So we can divide out 50 from each. So we'll get 1 and we'll get 200. So what we found is, now remember, that's in tens of thousands of dollars. So this is, why don't we answer this in words as well? The cost is, so 200, which is in tens of thousands of dollars. So tens of thousands would be 4 zeros. So the cost is $2 million. Crazy, huh? All right, why don't you guys try the next one? Okay, let's see how you did. So C is 200x all over 100 minus x. Now we're removing 60%. So x would take on a value of 60. Wherever we see an x, we're putting in a 60. So C will be 2 times 6 is 12. We're going to have 3 zeros over 40. So 40 goes into itself once and into 12,300 times. So C is 300. So the cost in this case is $3 million. So here we go. Describe what is happening to the cost of the cleanup as the percentage of contaminant removed increases. Well, the cost of the cleanup increases as the percentage of contaminant removed increases. Okay, so there you have it. We're finished with chapter 1. Study hard, my friends.